Welcome back, guys. I hope you had a good break. I hope you had a great Christmas and a New Year. We're going to get back to business here. We're going to transition in third quarter into systems of equations. We spent second quarter talking about all linear equations, and now the linear equations we're going to be talking about a system. A system is two sets of equations, and actually could be more than two, but for our purposes, it's going to be two equations that are going to be working together at the same time. You've got notes that are on your Teams page and example problems that are built into all of it. If you want to print all of those off ahead of time, that would be a really good idea. If you haven't already printed it, then you can print it afterwards, because I'm going to go through and kind of use all of these examples as part of it. So let's go ahead and get a share screen going on over here. We're going to be working with a couple different things. So we're going to go to the .cam first, so we can go through and talk about our notes here. We're going to spend probably, I would say, close to 2 or 3 weeks working on systems of equations. So we're going to start off with solving systems using graphing. First of all, the solution for a system is an ordered pair, x comma y, that satisfies both equations. Basically means when you plug them in for x and y, it's going to make true statements. And visually, it's where the two lines cross. So when you draw your two lines, they're going to cross in a particular place. That's the solution. Now, the process for doing this is to write both equations in y equals mx plus b, because y equals mx plus b is our shortcut for graphing. We're going to graph both equations. After we graph both equations, we're going to want to find the place where they intersect, find that point of intersection, and then to check our answer, we just plug into the equations to see if they work. So again, if you want to pause here and get these notes, you can. We're going to go ahead and work our way through this. And we're going to start with just a review on graphing. How do we graph using the shortcut? So I've got 3 examples here. The first 2 are already in mx plus b. And then a reminder about how we take an equation and get it into mx plus b. So remember, mx plus b, this is the m and this is the b. So the shortcut for graphing was to start with the b, because that's your y-intercept. And so my y-intercept for the first equation is -4. So on the y-axis, I'm going to put my starting point here at -4. And then I need to use my slope, and the slope for this one is 2 over 1. So from this point, I'm going to rise 2, run 1. Rise 2, run 1. One of the things that's super important when you're doing systems is not a bad idea to get as many points as you possibly can. Use that slope pattern and fill the entire grid, because I'm going to need to see where 2 lines cross each other. And so the more accurate the line, the better chance I have of actually getting that intersection point. Now, we're not looking for where lines cross just yet. We're just reviewing how to graph. So that's just a reminder there of how to graph using the shortcut. Now let's take a look at the second example here. We'll use a different color. For the second example, I'm going to start with my y-intercept at +5. So I'm going to go up to 5. And now my slope is -2/3. Now remember, only use that negative sign once. I like to give it to the top of the fraction. So that's going to make this rise -2. So I'm going to go down 2, and then I'm going to run 3. 1, 2, 3. Down 2, run 3. 1, 2, 3. Down 2, run 3. Now let's go the other direction. Let's go up 2, and let's go backwards. 1, 2, 3. Up 2, backwards. 1, 2, 3. So remember, you can take that slope pattern and you can use it in both directions. I'm going to go ahead and draw my line here. So a review of the shortcut. Now, if this was a real system of equations, we'd be looking for this spot right here. That's where the 2 lines cross. That's the solution. Now, for this example, we don't care because it doesn't actually cross on the grid. So figuring that out is actually going to be very difficult on the graph. But we'll talk about that on the next screen. And then I just want to review here, what happens if it's not in mx plus b form? Well, we need to get y alone. So if we're going to work to get the y alone, we then need to subtract 2x to both sides, bring down the 3y, put the negative 2x in front, and then the minus 6. And then we're going to divide out the 3. So y equals negative 2/3 x, and then negative 6 over 3 is negative 2. So this was just your solve an equation skills that we used in second quarter to get the letter y alone, and then we'd use the shortcut to graph that one there. Okay, so that's just sort of a brief review of your mx plus b graphing. If that's something that you need more practice on, then before we go through systems, you may want to just go ahead and pause the video and then go practice your mx plus b and how to graph using the shortcut. We're going to go ahead now and go back to the systems. Remember, systems, and let's bring back the notes here. Your systems, you are going to be graphing both lines, and the solution is where those two lines cross. So let's look at different examples about how that's going to work with our systems. And we're going to learn why we use systems and how to use systems as we go further. So I'm going to start you off pretty basic here. There's two equations, y equals x plus 1, y equals negative x plus 7. Remember, if there is no number in front of the x, there is a 1 there. So one of those slopes is 1, the other slope is negative 1. So we're going to start by graphing. Well, my y-intercept is plus 1, so I'm going to draw a dot here at plus 1. And then the slope is 1, so as I make that a fraction, that means rise 1, run 1. So up 1 over 1, up 1 over 1. Draw a whole bunch of dots here. And I can continue back in the other direction. This is going to be able to get a pretty accurate line here. It's really important that when you draw these lines, you fill the grid, because we're looking for a point where they cross. If you don't draw that line through the whole grid, you might miss the place where they cross. Now I'm going to go ahead and switch colors here for the second one. My y-intercept is up at 7, so I'm going to go up to plus 7. I'm going to put a dot right there. And this slope is negative 1, so that's going to be down 1 to the right one. Remember, use the negative once. Now we will draw that line. One of the reasons why I want you to draw as many points as possible is because very often, especially with these problems that are set up for graphing, you're going to actually see instantly where that intersection point is, because you're going to put a dot there for both lines. So this one right here, that is the point of intersection. That's the place we're looking for. So the solution to the system is the ordered pair for this point right here where the two lines cross. So this ordered pair is over 1, 2, 3, up 1, 2, 3. So this is 3, 4. That is the solution to the system. The point, the ordered pair where the two lines cross, is your solution. All right, so let's take a look at another example here of lines that we will potentially see. This one, we're going to have two things that we're going to have to think about, because these are actually really easy, but they sometimes confuse us. This first one says y equals x. Well, there's a couple of things I want you to remember. One is if there's nothing there, there's a number in front of the x. And then I'm missing the y-intercept, so there's a plus 0 there at the end. And then x equals 4 should jump out at you if you did your job third quarter, because that's a special one. And you were supposed to memorize the special ones. So I'm going to give you a moment here to think about an x equals and what kind of line that is. An x equals 4, that is a vertical line. So this one's going to be vertical when we get there. So let's start with the first one here, y equals x, which is now y equals 1x plus 0. So I'm going to start off here at 0. And then I'm going to have a slope that is 1. So that's going to be rise 1, run 1. And we're going to go ahead and then the second one is a vertical line, because x equals are vertical. Remember, if it was just y equals a number, that would be horizontal. X equals 4 means on the x-axis, I'm going to go to 4. And I'm going to draw a vertical line right there through that 4. Missed it there a little bit. So there's your vertical line. And we're going to now look for the point of intersection. And that point of intersection is right there. And so the ordered pair for that is going to be 4, comma, 4. So you're going to have vertical lines and horizontal lines that also come into play with our systems. So what I wanted to take a look at now, and let's stop sharing that screen, your assignments for the systems unit are going to mostly be on IXL. So what I want to do now is I want to share screen so you can see how it's going to work on IXL for this particular assignment. So I'm going to bring this up here. You should now see the IXL screen. And it's going to start off at the top, solve the systems by graphing. First graph the equations, then type in the solution. So they're going to give you 2 equations here. And then on the grid, they're going to want you to graph it. Well, this is actually going to be easier to graph than it would be on pencil and paper, as long as you know the shortcuts. So we're going to come down here, and you're going to see that there's 2 equations, and they're the same 2 up here. They're already color-coded, and you're simply going to click on the equation and then graph. So I'm going to click the first one here. Now for the shortcut, the y-intercept is +2. So at +2, you're going to draw your first dot. And there you go. There's your y-intercept. The slope is -5/4. So from here, that's down 5. 1, 2, 3, 4, 5. And then run 4. 1, 2, 3, 4. And you'll see the line starts to develop as you do it. And as soon as I click this second dot, boom, it draws the whole line for you. I'm going to click over to the green one. The y-intercept is here, -5. So I'm going to go down 5. I'm going to draw my first dot. And then the slope is 1/2. So that's rise 1, run 2. Boom. And it draws both lines for you. And now I am looking for the point of intersection, which is right here. So the point of intersection is over 4, down 3. So the solution is 4, comma, and then I'm going to type in -3. And then I submit it. So you're going to graph both lines using the MX plus B shortcut. And then you're going to find where the 2 points cross and you submit. It looks like it had expired there. So yeah, it had expired. So it was logged off too long for that to work. But that's the same basic principle there as far as how you're going to graph it. So one whole component is going to be graphing the 2 lines and then finding the point of intersection. Now, the last part of your notes talked about checking that answer. Well, part of checking the answer is also going to be, is something a solution, yes or no? And that's going to be another piece to this particular unit, is testing if something is a solution. So that's part 1. Part 2, we're going to start now. So if you want to pause the video and work on one of the IXL sections, you can. Now, if this is through class, I'm going to show both because we're going to spend the next 2 days working on this. So we're going to go ahead and share screen again here for part 2. So back to the dot cam here. Is something a solution? How do we test if something is a solution? Well, they're going to give you an ordered pair, and that's an x comma y. The answer to if something is a solution is always going to be yes or no. Now, I could graph both of these and see where they cross. And if they cross at 2, 1, then yes, it's the solution. And if it crosses somewhere else, then no, that's not a solution. But these equations are going to be super messy to get y alone. So the other way we can try to figure it out is to plug in the ordered pairs into both equations. So I'm going to start off with x plus y equals 3. And I'm going to plug in 2 for x and 1 for y. So the x value gets replaced with 2 because that's what it is in the ordered pair. And the y value gets replaced with 1 because that's what it is in the ordered pair. And does 2 plus 1 equal 3? And the answer is, yeah, it does. So I'm going to put a smiley face because I don't want to write yes right now, because I have to test this in both ordered pairs. Excuse me, both equations. So this ordered pair I have to now test in the second one. So 15x plus 19y equals 9. It has to work in both equations. So I'm going to go ahead and put the 2 in for x and the 1 in for y. So this is 15 times 2 plus 19 times 1 equals 9. So 15 times 2 is 30 plus 19 equals 9. Does 30 plus 19 equal 9? The sad face goes in here because that's not true. So when the question asks, is this the solution to the system? You would now answer, no, it is not. And the reason it is not is because it didn't work in both equations. What would happen is that 2, 1 would actually land on this line, but it wouldn't land on the line for the second equation. And in order for it to work, it has to be on both of them because it's the point of intersection. So let's look at a second example of whether or not something is a solution. Now these are in mx plus b, so I could graph them and that would not be terribly difficult. But let's go ahead and do it algebraically. So y equals 4x plus 4. And this is the x and this is the y. So the y is going to get replaced with 8 equals 4. And this is going to be times 1 plus 4 because I put the x and I put the 1 in place of the x. So 8 equals 4 plus 4. We have to think to ourselves, is that true? And the answer is yes. It's a smiley face because it is true. So let's test the second equation. Y equals x plus 7. Again, I'll plug in the 1 and the 8. And I'll plug in the 1 for the x. Is 8 equal to 1 plus 7? We get a smiley face again because that is true. So to answer the question, is 1, 8 a solution to the system? You would now answer yes, because when I plugged it in, it worked in both equations. That means it lands on both lines. And there's only one dot that could land on both lines, and that's the dot where the lines cross each other. So the second IXL section is going to ask you to say yes or no, these are solutions. And you're simply just going to plug the ordered pair into the equation to test whether or not it works. Now, those two sections are going to take us through the first couple parts of systems. Now, I'm going to go ahead and continue this video for the next sections, but we're going to go ahead and you can pause it here and do the first couple sections of IXL and then come back to the video and resume it at this point. When we start talking about the next phase, we're going to talk about how many solutions there are. We're going to talk about why. There are 3 types of situations for a system of linear equations. I'm going to have a situation where there is one solution, and that's what we just worked with. It's where the 2 lines cross each other. But there's also going to be situations where there are no solutions and infinitely many solutions, infinite solutions. Now, I want you to think for a moment, what could happen to 2 lines where I would never have a solution? And then what could happen to 2 lines where I have an infinite number of solutions, meaning the lines cross infinite number of times? So if you want to pause here and think about that before you resume, that's not a bad idea. We're going to go ahead and now share screen, and I'm going to show you the three situations that happen. So you're going to have one solution, no solution, and infinitely many solutions. Well, one solution is the typical type of problem where I'm going to have one line here and another line here, and there is a point of intersection, and that point of intersection is right there. So you're going to have two lines that cross each other, and there's going to be one solution. No solution means the lines will never, ever cross. So what kind of lines will never, ever cross? You got it. Parallel lines will never, ever cross. So I'm going to have one line that looks like this and another line that looks like this. And parallel lines will never, ever cross. So parallel lines are the ones that make no solution. Now, what do we know about parallel lines from second quarter? Parallel lines have the same slope. So if you have two equations that have the same slope but a different y-intercept, then they're going to be parallel. They're never going to cross each other. Well, what could we do then for infinitely many solutions, meaning they cross lots of times? Well, to have two straight lines cross each other lots of times, I'm going to have one line there, and I'm going to have another line right on top of it. They now cross infinitely number of times. They cross here and here and here and here and here and here, and they continue to cross each other an infinite number of times because the line goes on forever. Well, what would have to happen? It would need to be the same line. And the only way you could have the same line is if we had the same slope and the same y-intercept. So if you were to graph them, they would have to have the exact same equation because that's the only way you could get the exact same line. Well, you can look at an equation and know right away what's going to happen based on the idea of the slope. So if I want to look at the graph, I can look at it and say, okay, it has this many solutions because of the slope and the y-intercept. So if I look at this here, how many solutions in this system? Well, if I looked at the equations, y equals 2x plus 4 and y equals 2x minus 3, what do I notice about these two equations that they have in common? They have the same slope. Now, if they have the same slope but different y-intercepts, means they're going to be parallel. So this one is going to be no solution. Now let's graph it to confirm. So I'm going to use the shortcut to graph the first one. And my y-intercept is at plus 4. And then my slope is 2 over 1. Up 2 over 1. So that's the first one. And then let's take the second line here. The second line has a y-intercept of -3. And the slope and the rise and the run is up 2. I graph that one. And those two lines are parallel. And therefore, when it asks how many solutions, we're going to say that there is no solution because the lines will never, ever cross. Now, if they did cross and there's one solution, you might have to tell me what that one solution is, and then you're just going to give me the ordered pair like we did before. So this is a multi-part video that's going to take you through the entire first week as we start going into the systems unit. Again, if you've got questions, bring them to class. And you can always go back and watch the video at any point in time if you're absent or if you just need to see it again. I hope that this is working for you guys, and have a great day.